go and open the, we will pass one example, so not the, okay, Jill, don't use my folder. No, I'm kidding. Just use 004. You don't have this file. This is, I moved it. So open the grid-based analysis. So far we talked about the skies, different type of the sky that we have, about the materials, and you kind of know what is the workflow. You have a geometry, you assign some material to it, then you put a recipe together which basically says what are you looking for, and then you run it. But it gets interesting when you have all this stuff and you can start changing the parameters of your model and see what will happen for every single change, right? So this example here, what we're going to do is we're creating a room, a single room, and then we will change the size of the window, and we will change the material type of the glass, and we want to see the effect of that on the results. So what I hope we can do in the next hour is to set this thing up and run some test cases, and then press run, and it will run all the cases, and we go for the lunch. While we are in lunch, it runs all the cases. We come back and we start looking to the results. This is the idea. And this is something like hopefully you get to do like in this computer lab. You just play run when you really set your model in the right way. You don't log off. You just switch user. People who are listening to me online, we will cut this part. So it will run it for you. And when you come back, you can log in. These systems are multiple login users, right? So you don't have to log off. And while this is running something for you, it doesn't mean and nobody else can use your system. Does it make sense? Kind of? Okay. And on the other hand, it means you can use all these systems to run for you at the same time. Because other people can use the systems while these things are running. Yeah, for the end of the semester. So now I show you, instead of using like a normal way that you do a model like what we did, box and all that stuff, I show you how you can use this panel, which is for preparing geometry to prepare your geometry in Honeybee. It doesn't mean you can't do it surface by surface. As we saw, you can use this component always and have every single surface here and assign a rad material, right? But sometimes you don't want to do this because it can be so much work, especially if you have a mass with like so many number of floors. But now I show it for you for a single building. So what I have here is a B-Wrap. I preview on this. This is a box, right? This is a box room. Nothing crazy. This is my input. Then I use this component, which called mass to zone component. I call it mass to zone because it's mainly useful for energy simulation more than daily. And in energy simulation, you know that it's zone-based. So what this thing does, you pass a geometry and it creates a zone for you. Where to find it? It will be here. Down here. There is an issue kind of because these things are user objects. They're not the real Grasshopper GHA components. If you do the trick that I showed you last time, it will show you a Python component because this is really a Python component. It's just like a Python component with all the code. So this trick won't work for Honeybee and Ladybug. So this is here. So what I did, I just passed this from here, and this one is set to true. The output, again, is a closed B-Wrap, but this closed B-Wrap has information. You see, it tells this is a medium office. How does it know this is a medium office? here, building floor-to-floor program. Like, it has a default value. You can change it to whatever you want. But right now, it doesn't change anything because you don't have the energy simulation component. It's mainly useful for energy simulation, so it assigns all the schedules and all the construction and all that stuff. Then you can say if it's conditioned, you can split it to multiple floors, but for now, we just use this box. Then what I do here, when you have the mass, you need to add a glazing based on a percentage. Especially in earlier stages of design, you just want to do a study between like 40%, 50%, 60%, all that stuff, right? This is what this component does. There is another component called glazing ratio or glazing parameters, and you can find it here. And it lets you to assign the percentage of the glazing for different directions. Right now, it comes from here, and this one is set to -1, right? So you get nothing as the source glazing ratio, and it doesn't generate anything. It doesn't add any window. But let me check if this thing, write rat file, is set to true. So go and set this thing to false. If you don't, it will run the analysis. Number 5, go and make sure you set this thing to false. Just write rat file set to false is enough. Everybody set this thing to false? Okay. Now go ahead and select, this is on -1, put it on 0. So as soon as I put it on 0, the percentage of glazing is going to be 0.5. And if you go here, I'm using the output of this component, which is a Honeybee zone, and I decompose it. So now this B-Wrap, if I just use a B-Wrap, you can see it, you can visualize it. This is a normal Rhino B-Wrap, which has a window added. But again, it has information included, so I can decompose this. And when I decompose it, it puts the windows here, it puts the roof here, it puts the floor here. So everything is separated based on the type. And how does Honeybee knows about the type? It's exactly similar to what I mentioned when we were assigning the materials. So based on the normal, it understands where is the roof, where is the floor, where is the walls, all this stuff. And it assigned the normal generic glazing material to my glass. But in this study, I want to change my material for the glass. So what I need to do is I decompose the zone here. I take the glass surface out, and I use the other component that I had, Honeybee create surface, to assign a new material. Do you remember like the very first class that we had? I create a box, then I decompose the box, then I use the wires of the box to create a window. The concept of composing something, constructing something, and then deconstruct that, and then use some pieces of that to generate something new. This is what we're doing here. I'm creating a zone using these components because it just makes my life simple. Because I do it pretty fast, it just assigns the window based on a percentage. Just now, as soon as I change this, it will change my window, and it definitely can be more than 2 values, and this is what we will change before going to line. So we will run it like for 10 different values, for example. And then, because I have this, so it did the job for me so far up to here, then I use decompose to get the different parts and assign the material that I want. So now, not only I want to parametrically change the geometry, I want to parametrically change the material. And where the material comes from, if you check the rad material, it comes from this component. And this component is a glass material maker. And what it needs is, again, I have a list of values for transmittance. So I just put this thing to 0. It will generate a material with TV's 40%. And you see this number is a little bit different. It's because this one is transmittance, the input number, the output number is transmissivity. We won't get there. Like, if you want to read it, there is a reference, or search for it. You will see what are the differences. So now I have this thing parametrically set. I can change the window, and I can change the material, right? As soon as I change that to sliders, it will update all my model. So I will get a new model which has a new percentage of glass and it has a new material, right? So if I have this thing set to run, it will run the analysis for me every time, right? And here, for the recipe, I put a daylight factor component. And the reason I did the daylight factor is because it's just fast. It's not what you really want to use for your analysis usually, right? And daylight factor doesn't ask you, daylight factor recipe doesn't ask you for a sky input. Why? It doesn't ask you any sky input. Why does it happen? Like, do you remember this one? It asks you for the sky file. Because you already know what is the sky. It's a cloudy sky, right? So it's just like, you know, this is the simplest recipe. It's just like cooking shows. We already know what is the sky, so you just have the sky there. And there is a discussion, like some people think uniform sky is the one that you should use. I don't think so. So you can set this thing to true if you think you should use uniform sky and not the cloudy sky. And it will change the result again. Like, because you can see in the 3D print, there are different skies. So in a cloudy sky, it's brighter on the top more than horizon. But in a uniform sky, it's all the same. I'm talking about this versus this. And something that I forget to say, you see when the sky changes to cloudy, the main source of light changes location. It goes all the way on the top. And it changes the way you actually, if you want to design for daylighting, think, right? Because the light source is now in a different place. So I put the daylight factor. Now go ahead and whatever you have like this thing set to something, this thing set to something. Just make sure none of them are -1. Like there's something, you selected something. Go and set this thing to true. Something happened. That's fine. Like for now, the component is what? Let's talk about if you couldn't find it. You're talking about this? This one? You don't have this output? You deleted that? So do this. No, probably you did something like, let me do it. You did something like this. Yeah, it went away. That's fine. That's totally fine. Just go ahead and bring a new one. And then just connect this thing here, connect this thing here. And then connect it to the analysis recipe. You should be fine. Solved. So something happened when I connected this, like you had like multiple windows like bum 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 popped up, right? That's fine because it doesn't say no light. It says there's no light source, right? Yeah, because it's searching for your light source right now is the sky. It's just giving you a warning there is no light source in. And it means like there is no light material thing inside because we don't have anything with light material assigned. There's a material in radiance called light. Like you have glass, you have light. That's a warning. You can just, that doesn't matter. So what happened, there are two things I want to talk about. One is, you see here number of CPUs. So what, like in radiance is on a Unix system, it actually has a key that you can set to use all the CPUs of your system. But on Windows, it only uses a single CPU. So if you have a really good machine, like 24 CPUs or something, it only uses the first one. And interestingly enough, many of the other softwares that you're using do the same thing. So you're sitting there all night, like for 2 hours, and it's only using one CPU. And you can see like the 23, they're just like relaxing. So this is what this thing does. It basically kind of fakes the process of parallel simulation. So it divides all the points in series. So if you have, I don't know how many I have here, but if I check the report, it will tell me. It says, sorry, but the number of CPUs on your machine is 12. Because I had here set to 24, it can't go to 24, so it set it up for me to 12. So it doesn't matter, put it in 100. Like whatever you have in your machine, it will use it the maximum possible, right? And then it will come here, and this is what I said. If you don't have these things set right, I will rewrite for AD, AR, and AA. So you can't go less than this. But if you have like a higher resolution, I won't touch that. But if you have a lower resolution for a grid-based analysis, I guess you don't know what are you doing. So I rewrite it for you. If you really know what are you doing, just go change the code inside. And then it set up all these folders, and it start running all that simulation. So when it is done with the simulations, it gives you its annual analysis path. I did the wrong one. So you should check the grid-based analysis path here, and this is all the results that we get from the simulation. So now we have all the results, right? The only thing we need is to visualize that result. We are done. So we had the geometry, we put the recipe together, we just ran it, and this is the result. So how to visualize the result is, first of all, we have to read this result. If you don't get confused, I will start down here and we do it together. We don't use what we have here, right? And we use that one later for multiple simulations. So what I do here is the result coming out from grid-based result paths, right? So these are the path of my result files. There's a component here that helps you read the RAD results. So you connect the grid-based result to this RAD results. Then it asks you for the test points. The test points are the other output here. You connect the test point. Then it asks you for the analysis type, and you connect the analysis type. This is the place that I said I made it hard intentionally. It could all happen inside this component. I didn't really need you to do all this stuff, but I want you to do all this stuff because I want you to start thinking like what's really happening. What are the analysis type, what I'm running, what type of result I get, and how it can be wrong, and what is the unit of that result. You don't want to run like daylight factor for all your life and think that's a lux value of 2 something, right? And do you know why daylight factor between 2 and 5 is a good value? So we talked about cloudiest sky, right? So if you imagine for a cloudiest sky, you consider 10,000 of lux horizontal, 2% of 10,000 is going to be 200. So 5% is going to be 500. Am I right, or am I adding 1, 0? I think I'm right. It's morning. I can be wrong. Everything like Sunday morning. So, but that's the concept. Like, I can't do simple math. So now I have the result. There is a component for that. This component does it for you. So it calculates. This is what it does. Actually, if I open this, so right now, what I generate the sky with 100, I think, or 1,000 here. So I divide all the values by 1,000, whatever I get. This is how it calculates the daylight factor, as I said. But I think a cloudy sky, of course, it's 10,000. It's not 1,000, but anyway. So now you have the units and you have the values. So the only thing you want to do is to visualize this. If you remember, when you have the values, so for each test point, you have a value, right? So you should be able to use whatever you had in Grasshopper. Do you remember how we use values to generate colors and assign them to the points? You don't? Uh-oh. Uh-oh. So this is how you do it. Let me do it for you. So we have the test points here, right? I have the values here. I generate some colors. I change the color set. Then this is between 0 and 1. If you remember, there were 2 ways. One is like to find the maximums of the value, to range of the value. So I use bound component. And then I decompose domain. Hopefully this is the last time I do this thing for you. You use this and this, and I do it backward because I want the more light I have, I want to see it more red, not blue. And then I connect my values here, so now I have all my colors that I'm looking for. I do a preview. I use a color as a shader, and I use my test points here, and this is your results. So what happens again, I found the bound of the numbers. I found the maximum and minimum. Generated the colors. So for each test point I have a value. For that test point I have a geometry. I connect them together. Here is my values. And now you can see the points. If you want to add the text, you can use this value and use the text 3D component that we had before. And use the points as the location. So I use the point output as the location, the points coming from this component. And use these values as the text. And definitely change the scale to something that fits. So now you can go and read the values, right? $38 here, 8% daylight factor here for this. And did we select the dark glass? Probably yes. So that's why the values are this low. So you see it was like, I did select the first one, which is 0.4. Now just go ahead and change 0.4 to 0.8. I just changed it to 1. What will happen, it will rerun all the analysis. And because this is an old version of Grasshopper, you have this bug in Grasshopper that a slider triggers 2 times. So it ran the analysis. I got the new result. You see now we changed this thing as something that can run the analysis with a single click. But this is not what you should have set up. You should set it up every time, I think, until you get really good at it. Now, this was a pain if you want to do it each time. So instead of doing this, as usual, you can delete this. And as Jill said, there is a component for that. So you go to Ladybug. There is a Recolor Mesh component. And what Recolor Mesh does, it basically gets the value and recolor the mesh. So you need the mesh. And where to find the mesh? The place that I generated the test point, and I didn't talk about it even. I forget, sorry. So probably we want to talk about this. But like the place that I generated the test points, it has a mesh output. So you can use this mesh and connect it here as an input mesh. So again, it's here. Generate test points for floor. Mesh, you connect it as an input mesh. And then you connect these values. And it will give you a colorful mesh. So I get the input mesh. And yes, this is Recolor Mesh. This is the component that I said there is a component for that here. It's in Ladybug extra. So we just recolored this. So now you get this. It has no title. It has unknown units. So you can start setting that things up. For example, you have the units here. So you can connect it to the legend title. So now this is percentage. And then you can say daylight factor analysis for whatever you did. So you just bring a panel and you type daylight factor analysis. I don't know. The glass type was TVIS 0.8. Was it 0.6? I don't remember. And that's why you should make this parametrically. That I will show you how to do it later. But like whatever you connect here as your analysis title, it goes here, and you need an extra enter. So now you have this thing set up, right? And you can see the values. And now this is not a useful graph because we are running a daylight factor simulation, and what we want to see is what is the area that we have it between 2% and 5%, right? But this colors doesn't show me something useful really. I want to go to the client and say, hey, look at this. Like this area of your building, like this percentage of area of your building, it potentially have a good daylight because it has a daylight factor a bit more than 5, right? Between 2% and 5%. So how you do it is, again, you change the legend parameter, which is, again, a ladybug component. It's not a honeybee component. So I just bring this one and set the high bound to 5%, which means whatever is larger than 5 will be red. Okay, how many people have questions? Like, this was fast? Okay, that was fast, I know. This is here for you. You can cheat while I'm helping you. And now think about it, like the next step what we want to do is, okay, I can have like so many iterations. How should I run all the iterations and go through and watch them? One way is just to run it like this that we ran and capture screen. Go again, run the next one, capture screen. Next one, capture screen. But I mean, that's not the best way, right? If you want to run like 10 different analysis, then you have to sit here like 10 times. Just while it's running, just like, find something else and come back. And that's what usually people do. But you can do better here with Grasshopper. Just go ahead, like if you were fine with this, go ahead and run an analysis, and this time use this component here and generate the illuminance values for that point. So I don't want you to get daylight factor. I want you to generate illuminance values. And I have it all set. You should just connect something to something. So I use go to the debug. I use this component, Recolor Mesh. And I use legend parameter. Yes. So what I did is use the mesh coming from input mesh, coming from where you generated your test point. I generated the test point. we got one here. I want to test what happened. I didn't check my material because I wanted someone to make a mistake. You are applying glass to the wrong wall. That's good. I was waiting to do it. So, what would this house give me a second. So what I would do before doing anything stuff is I go here and I read my geometry map. Where are your side surfaces? You didn't connect them to the component, they're disconnected. I can show you where it's at. Where's your wall? Why your walls are not connected? Where are the walls? Why you don't have that input? Why you like to remove input? Here. So if you have the right component, it has one extra input here, which is walls. Then you're removing where it gets removed from your component. That's weird. But like you don't have the walls. This is what I'm talking about. Like if you don't check your geometry. Okay, you see proof of concept. So this will happen for you. Check your geometries and check your material. I didn't check it. I was waiting for someone to make a mistake. Thank you. And thank you, Rory. You got like a plus. So let's have delete. Okay. Oh, your job. So anybody did run the luminance analysis? You don't know? I know you didn't. Can you see it? Did you? So you only need to put the recipe together, and there's one thing missing from the recipe. Go check the recipe for the luminance analysis. Did you run this test? So what I'm missing here, like here. What I'm missing here? Weather file. Just assign a weather file. What? Just assign a weather file so you get the other recipe ready. You can do it. It doesn't really matter as far as you have a file path. That's fine. As I said. The components are there to just make your life easier. It doesn't mean you have to use them. So when you run it, probably you will get a result that doesn't look good because of the legend setup. So you should go fix your legend. And I want you to give me some result that makes sense, like that you can put it somewhere and say, okay, this is I ran, and this is I think this because of that, you know. make a statement based on your simulation. So this was the first part. I was missing the weather file. I just added the weather file, so I have the recipe here. I connect the recipe here, and because everything is already set to true, it will run the analysis. And this is what I got. Right. You did it? Awesome. So how many people did, like, anybody still has an issue? I can help you if you have. No? Can you help her? Thank you. You're fine? No? Okay. I'll be there. That's fine. If you did it and it works, now run it like for 9, 12, and 15 instead of only, if you're running it for an hour, so you can see the change when the sun moves, how it moves inside. So what you're trying to do. Okay, now let's do one thing. Let's try to set up your new simulation, right? So you have your geometry set, right? And the only thing you need to instead of a new recipe, right? And for this recipe, you need a sky file. And inside the sky file, the weather file is missing, right? So you need to provide a weather file. How do you provide a weather file? Just exactly. So just go select the input of the weather file. And then okay, you got it. So now I'll do a visualization with you together. So you're doing fine, everyone? You did it? Ali, you're fine? Yeah. Okay, awesome. And just go here. And why? Oh, okay, that's, you need to press to enter. You have to come carrying it on your own. So that's a smart that you using that output as a legend. So the only thing that you need to do is you need to concatenate it. So concatenate is basically you connect these systems together. So I generate this thing and I press, I go here, press enter. Yeah, and then I connect this. Okay. Yeah, I typed it in, but like a better way is actually to use, because you want this thing to change parametrically kind of. Here, analysis type, you can use this, so you can connect this, but there will be an issue because it goes inside your geometry. So if I connect this analysis type, whenever I do a different analysis type, it will change it. And how I can get it out of there is I concatenate that with two inters. So this thing is like enter on the top. So I just insert concatenate. And I connect this analysis type here, and then I connect it here. I think this is something that I should get fixed more than you. So, oops. So now this is illuminance, and it comes from this component. So if you run a different type of analysis, it will change. So now where we are in this graph again, I hope you guys are here now. So everybody just ran an analysis, and you can just easily change it, right? So for example, now I run it for 10 a.m. If I want to run it for 8 a.m., or if I want to run it for noon, I mean, I have the worst presentation ever, and I just leave it like that for now. So I just changed the hour.